The assignment operator makes the CPU do things. The assignment operator assigns a value, it changes things in RAM. That's why a line such as this one is called a statement and ends with a semicolon, because it changes something in RAM. We can of course use the assignment operator to reassign to a variable as well. The data type, the label, the value, these are not new things. I just wanted to repeat a little bit to make it stick. One way to look at it is that the value 100 is packed up using binary code, just binary data, and then it is put into the variable in memory. You can also pack up a string literal into binary code, and then you store it in the variable of type string. As you can see, the actual slot in memory is called a string, but if you hard code the value of a string, then it is called a string literal. There are many different ways to hard code things. If you hard code an integer, you just type a number. If it's a floating point numeral, then you need to put an F afterwards, and string literals need to have quotation marks. And of course, if you pack up a class, you use the class name instead. In general, hard coding values is a bad idea. You can do it while you are developing your program, but once you're getting closer to actually giving it to somebody else to play around with, you should have removed all hard coded integers and string literals, and should have them in a data file on the side instead. Now, why do I bring this up? Well, partly to repeat, but another thing too. As I said, this is a statement. We have 3 statements on screen. These 3 lines are all statements. They do something. They change things in RAM. Relational operators are used to check if something is true, and then if that is true, then we can put in some statements to use that to execute statements only if it is true or only if it's false. The 6 most common ones, common relational operators, are these 6, and you use them by putting them between 2 different values, such as here. The computer will first evaluate this expression, and once it has returned true or false from evaluating that, then it will execute the statement. In this example, 42 is greater than or equal to 23, which means that the expression will return true, and true will be assigned to result. In this example, 23, the string literal, is not the same as 23, the integer. So this will evaluate to false. And these 2 are statements because we use this expression to have something to assign to answer. So let's say that we are assigning false to answer. If we then have an expression to check if answer is true, then this expression will of course return false because answer is false. In this case, we can make the code a bit shorter, and we can just use answer as an expression all by itself. And since that is false, it will of course return false as well. We will use this in a moment. Logical condition operators, they can be used to make condition statements more flexible because you can combine several clauses. Each expression gets evaluated separately, and then they are compared with each other using these logical condition operators. Here you have an example. First, 42 is less than or equal to 23 is evaluated, and that returns false, as you can see. But since we're using the logical not operator, then we will turn that false into a true. Since this one is true, the computer will move on to check this one as well. If this one would have been false, then it doesn't matter if this one is true or false. Since we're using the AND operator, the total expression will still be false, which means that the computer would end here if this was false. But it's not, so it keeps going, and it checks if 42, oh, that should be, sorry, that should be not equals 23. And since 42 not equals 23, then this evaluates to true, and then the logical condition operator gets evaluated. If this is true and this is true, then the entire expression is evaluated to true, which gets assigned to result. Now, all of these expressions, they don't do anything like statements, so that's why we need to have this assignment part here, otherwise it wouldn't be a statement. But sometimes you want to use an expression not to assign, you want to use it to check if something is true. If it is, then you want to execute a bunch of statements. For example, you want to call some methods. And for this you will use the if construct, or an if statement, or an if else statement. Let's say that we have two variables. We define question as false and answer as 42. If the expression inside the parentheses evaluates to true, then the code inside the container will be executed. If this evaluates to false, which is the case at this time, then the code in here will be skipped. You could end here and not do anything more, but if you want, you can make another if question, and this one only gets executed if this one returned false. If this one returned true, then this one would never be done. It would never get there. It would skip all of it. But since this one was false, then it will check this one as well. And the question was false, so this one will return false as well, and the code here will be skipped. And then it jumps down to the next one. It evaluates this expression as well. Since not question returns true and answer is 42, then this code will be executed. And you can also, if you want, have just an else statement with no if. This means that if everything else up here evaluates to false, then this will be executed no matter what.